Definition of gradient and the difference in meaning with slope. As stressed in the tutorial introduction, in many textbooks the terms slope and gradient, especially in the basic level ones, are considered as having the same meaning. This can lead to confusion, so it is important that we clarify the difference between them. Therefore, the first thing we will do in this tutorial is to explain the differences between these two terms, so that you will have a clearer idea of why a certain term is used in a specific situation. In mathematics, when using the word slope, we commonly refer to a certain inclination that causes a motion, a line or a surface to diverge from the vertical or horizontal direction. Unlike in everyday life, where this term is associated with the inclination of a surface, the term slope in math is mostly used to describe the overall feature of a graph without going into numerical details. In a certain sense, the term slope is a synonym for steepness. The term gradient is more number-oriented. It describes the rate of inclination in the sense that we have to calculate how much the vertical shift changes with respect to the horizontal shift. When the position of a mathematical object, it can be simply a point, changes. As we have seen in other tutorials when dealing with a 2D graph, we make all calculations based on the origin of the coordinate system, which we consider as a reference point. In this sense, when giving the coordinates of a certain point, we tell how far from the origin this point is in the horizontal and vertical directions. However, a line is not made of a single point but of an infinite number of points. Therefore, all graphs, linear and not, contain an infinity of points that change their coordinates gradually when shifting throughout that line. Look at the graph in the following shown on screen. All points shown in the figure belong to the same straight line. Since the line has the same steepness everywhere, we expect the gradient of this line to be the same number. Indeed, as we covered earlier, the gradient k of a line represents the change in the vertical coordinate divided by the change in the horizontal coordinate. When calculating the gradient of a line, we usually consider two known points and use their coordinates to find the value of the gradient. In symbols, we write the following shown on screen. Where x, 1 and y, 1 are the coordinates of the leftmost point while x, 2 and y, 2 are the coordinates of the rightmost point considered. In linear graphs, we can use any 2 points to calculate the gradient as the result will always be the same for any pair considered. Let's confirm this assumption by calculating the gradient of the line shown in the figure. Thus, taking the points A and B yields we have the following shown on screen. When taking into consideration points B and C, we have the following shown on screen. And so on. As you see, the gradient of a linear graph is the same, no matter which points we take into consideration for calculating it. In our example, the gradient is 2. This means the y-coordinate changes twice faster than the x-coordinate in this graph. In this way, we obtain an alternative definition for the gradient. The gradient of a linear graph shows how much faster the y-coordinates of any 2 points of that graph change compared to the corresponding x-coordinates. In the functions-related terminology, the gradient is known as the rate of a function's change. However, for now, we will not delve too much into that part of the mathematical analysis. Example: use the coordinates of the 2 given points to calculate the gradients of the lines and shown in the figure in the following on screen. Solution: since we have a linear graph, we can take the coordinates of 2 points anywhere in the graph to calculate the gradient of the given lines. Often, it is preferred to take the intercepts with the x and y axis since at these points one of the coordinates is 0, but this time we will take only the y-intercept, as the x-coordinate in the x-intercept is not clear from the figure. Therefore, for line we consider the 2 points A and B in the figure, while for line, we consider the points C and D in the figure. From the formula of gradient, we have for the gradient of the first line, the following shown on screen. As for the gradient of the second line, we have the following shown on screen. That is all for lesson 14.2.1. To continue this tutorial, please watch 14.2.2. What does the sign of the gradient indicate? Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.